Okay, so here we are in section 9.7, linear and nonlinear functions. So it's easy to tell by looking at the graph if it's a linear function or not. Because remember, linear means, it means line. That's the first four letters. It means line. So basically, its question is it a line or not? Well, number 9, yes, that's a line. Number 8, is that a line? No. Yes, it's a line. No, it's a curve. It actually has a name. It's called a parabola. And satellite dishes a lot of times are shaped like this. They're a little wider, but it's the general shape of a satellite dish. So that's 8 and 9. Now for 12, 13, and 14, we're talking about equations of lines. So basically it's y equals mx plus b that we're looking for. So first of all, y and x can't have exponents other than 1. If they do, it's not a line. Okay. And then it's got to be some number times x, and it can be a number plus or minus there, but doesn't necessarily have to be that way. For instance, number 12 is, yes, it's a line. What it'd be in slope-intercept form is y equals 3x plus 0. Okay. So it's in slope-intercept, there's nothing added to the 3x. Okay. 13 is also a line. You might say, well, there's no x, but yes, that's because that is y equals 0x plus 7, where the slope is 0. So yes, it's also a line because it's in slope-intercept form. Number 14 isn't though, because notice it's x times y, and are x and y being multiplied in this case? No, I'm multiplying x by a number or by m. That's not what y is. So no, I'm multiplying x by y. If you want to know what that looks like roughly, it looks like this. If I were to graph it, looks like that curve there, and it's called the hyperbola. Next, 16 and 17. Okay, 16 and 17. Now, if it's going to be a line, it has to have a constant rate of change or a constant slope. So let's see if it works that way. So for number 16, I'm adding 1 to the x's, and I'm subtracting 5 from the y's each time. So the change in y over the change in x is the same every single time. So yes, constant slope. Okay. If I look at number 17, okay, I'm adding 2, I'm adding 2, I'm adding 2. So far, all the x's are constant. They're adding 2 each time. The y, I'm adding 3, then I'm adding 2, then I'm adding 5. So no, not a constant slope. I have no idea what this graph would look like. Okay. All right, and then the last example to take a look at, number 22. Oh, this barely fits in here. Adam puts $15 into a savings account every month. Suzanne tries to double the amount of money in her bank account every month. Not including interest, which person's monthly balance represents a linear function? And explain why the other person's balance is best represented by a nonlinear function. Well, let's look at Adam's as a table. And then we'll look at Suzanne's as well as a table. So after 1 month, Adam has $15. And he's going to put $15 in there every single month. So it means add another 15, 30. Add another 15, 45. Add another 15, 60. That's enough to get the idea that I'm adding 1 each time to the months. I'm adding 15 to the money. Okay. So that's linear. So Adam is linear. Okay. Now if we look at Suzanne, 1 month she has, let's just say, 15 bucks again, like he did. Well, she wants to double her money every month. So she has this next one, 15 doubled is 30. Well, so far this looks the exact same as Adam's money, so we'd think, oh, this is a line. Except for after the 3rd month, I'm not going to add 15. I'm going to double this so it becomes 60. And after the 4th month, to double that so it becomes 120. So we end up having 15 that we're adding, then plus 30, then plus 60. Okay. So this is not the same. So Adam's is linear, and Suzanne does not have a constant slope. There we go. And that is it for section 9.7.